Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video, we're going to look at solving equations. Now, before we start looking at equations, I want to talk about the difference between an expression and an equation. Because in all of the previous videos, I've been talking about expressions. And this is an example of an expression. It can contain numbers, it can contain operations, it can contain grouping symbols, letters, and so on. And the whole purpose in working with expressions, the whole process is about simplifying. We want to simplify an expression, carry out any operations, and express our result in the simplest form possible. On the other hand, an equation, it looks something like this. An expression equals another expression. And there's two very fundamental differences between an expression and an equation. With an expression, all you're doing is simplifying. However, with an equation, there might be some simplification involved, but your motive or your purpose is to solve the equation. You want to find what the variable or the unknown is equal to. So that's a big difference. We're not just simplifying, we're solving. The other big difference is that with an expression, you cannot change its value. You can manipulate it, but it has to be equal to what it started off as. With an equation, you can perform whatever you want. You can add, subtract, multiply, divide, but the rule is whatever you do to one side of the equation, you have to do it to the other side. So it's a different process working with equations than with expressions. We still use some of those rules, or many of those rules, but we have a different purpose in mind and we can do more manipulation. So let's not start off with this equation. Let's start off with basic equations, and we will build up as our knowledge increases. We will get increasingly difficult equations to solve. What you're going to find initially is that your equation is going to have some unknown, and we call that a variable. So you might hear it called an unknown. You might hear it called a variable. I'll probably use both terms. So what we want to do when we're solving an equation is figure out what that variable or unknown represents. It represents a number that makes the statement true. When you're solving an equation, you can perform any operation as long as you do the same operation to both sides. And the operation that you're going to perform is always the inverse operation to what is with your variable. You want to get your variable by itself. So in this example, I have t plus 13 equals 25. 13 is being added to the t. So in order to get t by itself, I need to get rid of that 13 that's being added. So I just subtract. I do the opposite operation. So if it's addition, I would do the opposite. I would subtract. So I'm going to subtract 13 from this side of the equation, and I need to do the same thing to the other side so that it stays balanced. You can't change one side without changing the other the same way. So that will cancel. 13 minus 13 is gone, and I'm left with my t. 25 minus 13 is 12. And you can always check your solution, this is called your solution to the equation, by just plugging that value into the original equation and seeing if it makes that statement true. So does 12 plus 13 equal 25? Yes. So we know this is the correct solution, and there's only one value that will satisfy that. In our next example, I wanted to throw in decimal values just to show you it doesn't matter if you're working with whole numbers, fractions, decimals, your process is always the same. You want to get the variable or the unknown by itself by performing certain operations, and those operations will be determined by whatever else is with that variable. So in this case, I have m minus 1.5 equals 18.25. To get rid of the 1.5, it's being subtracted. The opposite or the inverse of subtraction is addition. So I'm going to add 1.5 to this side. I'm going to add 1.5 to that side. So on this side, you're going to have m minus 0 because minus 1.5 plus 1.5 is 0. And then on this side, I'm going to have 19.75. Again, we can plug this into our original equation and check to see that it does make our statement true. So 19.75 minus 1.5, yes, it does equal 18.25, so I know my solution is correct. Let's look at some more. Okay, in this next equation, we have 5a equals 35, and you need to understand that when things are written beside each other in algebra, it means multiplication. So this means 5 times a is equal to 35. So we want a by itself, it's being multiplied to the 5, so the opposite or the inverse of multiplication is division. So I'm going to divide this side by 5, and that's allowed as long as I do the same thing to the other side. So I'm going to divide that side by 5. Now in this case, the 5 will cancel, and I'll be left with a. 35 divided by 5 is 7. And again, do a quick check. Does 5 times 7 equal 35? Yes, it does. And your numbers don't always work out to whole numbers. You could have fractions, you could have decimals as a result, which we will get into as we proceed with these. The process is the same. In this example, b over 8 equals 2. That means division. So to isolate my b, I want to perform the inverse or the opposite operation of division, which is multiplication. So what I'm going to do is I'm going to multiply this side by 8, and I therefore need to multiply this side by 8. In doing so, the 8 will cancel, and I'll be left with b, and my result will be 16. Does 16 divided by 8 equal 2? Yes, so we know we've performed it correctly. Let's look at some more. I think we're ready to move to an equation that has a combination of operations. The objective is still to isolate our variable or our unknown, but there is a certain order that we need to do that. We first of all need to get the term containing that variable by itself. So if we take a look at this example, I want to isolate this term first. If you start dividing by the 2, you're going to run into issues because you need to not just divide this term by 2, but if you're going to divide this side of the equation by 2, you're going to have to divide every term by it. So my suggestion is isolate the term first and then worry about that 2 coefficient. So my first step, I'm going to add 15 to both sides because I want to get rid of this 15 that's being subtracted, and the opposite of subtraction is addition. So I'm going to be left with 2c plus 0, because minus 15 plus 15 will be equal to 0, equal to 10 plus 15 is 25. So that's my first step. My next step is then to isolate my variable by getting rid of this 2, which we know means it's being multiplied to the c. So we're going to do the inverse or the opposite. We're going to divide by 2. If I divide this side by 2, I have to divide this side by 2. That will cancel, and I'll be left with c equals 25 over 2, which you can leave, that's correct, or you can write it as a decimal, so that would be 12.5. It depends on what you're going to be doing with that result as to what form you want your answer in. So both of these are correct answers. And again, you can plug it in and check. Does 12.5 times 2, which is 25, minus 15 equal 10? Yes, it does. So probably when you start off with solving equations, they will be asking you to check your work. So that just means you take this value, plug it back in, confirm that it is correct. So that would be what you would do if you're asked to check. My next example illustrates what to do if you have your unknown in more than one term. So in these types of equations, the goal is to get those terms all together, combine them on one side, and then everything else can move to the other side. So in this case, I've got 3a here, and I've got negative a here. I usually want my coefficient for my unknown to be positive. So you always move the terms in the way that you will end up with a positive coefficient for your unknown. You can't control the other ones, it's more the unknown. So instead of moving 3a to this side by subtracting the 3a, I'm going to move the negative a over here by adding an a. So I can do that. I can add an a to this side as long as I add an a to this side. And remember when we were talking about adding and subtracting polynomials, you can only add and subtract like terms. So 3a plus a, those are like terms, is 4a minus 2 equals 10 minus a plus a, it will be a 0. So now this equation looks very similar to what we just did. Our goal is to get this term by itself first. So to do that, I'm going to get rid of the 2 that's being subtracted. The inverse of subtraction is addition, so I'm going to add a 2. And I need to add a 2 to this side as well. So that leaves me with 4a plus 0 equals 10 plus 2 is 12. It's getting simpler and simpler as I go, and now I just need to eliminate or move that 4 to the other side. I need to get a by itself. This is multiplication, so in order to move it, I would divide. Cancel the a, or the 4, sorry, and I'm left with a equals 12 divided by 4, which is 3. We can check it. This 3 times 3, which is 9 minus 2, which is 7. Does that equal 10 minus 3, which is 7? Yes, it does. So we know that that solution is correct. These next 2 examples are equations that you'll encounter quite often, especially if you're working with proportion. And the process for solving these, there's a special process. It's the shortcut for doing what we were doing with the other equations, and it's called cross multiplying. And in order to cross multiply, you go across the equal sign in a diagonal motion, and the product of those 2 values, so 17 times p, will equal 4 times 10, which is 40. So that process will always work when you have that type of equation. And then we continue on with our solution the way that we have been. We isolate our p, in this case our unknown, by, in this case we're going to divide by 17 because 17 is being multiplied. The 17 will cancel. We're left with p equals 40 over 17. My personal opinion is leave your answer as 40 over 17. If it turns into a nice even decimal, you can do that. In this case, it won't. And I like exact answers rather than a decimal value that you eventually have to round off. So I typically only round off at the very end of all of my calculations when I'm doing a series of calculations. So I would rather have the exact value expressed. Now your textbook or your teacher might require you to do something different, but I'm just going to stick with exact values. In this example, my unknown or my variable was in the numerator of one of the fractions, but it could be in the denominator and you'd still do the same process. So we're going to cross multiply. So 2 times n will equal 3 times 8. And then we isolate our variable by eliminating the 2, and the way that we do that, that's multiplication. So we divide, do the same thing to the other side. So my solution is n equals 12, and we can go back in and check to see if that's correct. I'm going to continue with more equations on the next video. So what I want you to do now is practice these types of equations. I call them basic equations. Make sure that you have a good foundation in these equations, and then I'll move on to, we'll progress to ones where we might have grouping symbols and they might start looking a little uglier. We'll see you on the next video.